connect these batteries under loaded condition. Okay, so what is the aim of your experiment? To connect two batteries in parallel connection of which rating? Same rating. So these are same or different rating? Same rated, 40 Ah and 40 Ah, and calculate its power and energy delivered. We have to calculate the power and energy delivered. Already I explained everything about this battery, how to test the battery, how to test the gravity level of this battery, and how to identify the voltage of this battery. So now resultantly you got one terminal is negative and this is negative negative are joined, positive positives are joined. You got one positive terminal and negative terminal, and we had started giving which connection? Fuse as primary protection, secondary protection is MCB. So now safety also we designed. Now we have to start giving the connections. When you start giving the connections, you can see here. So now the positive terminal is entering into the ammeter and it is leaving across the ammeter, and it is entering into the positive terminal of the rheostat and it is leaving at the output of the rheostat. I can say that this ammeter and rheostat are connected which connection? Series connection. Okay, so now in order to exhibit this, you see here I am explaining the same connection. So you got a positive terminal from here. Okay, so this is the positive terminal. So from positive terminal, it has to go to the positive terminal of the ammeter. Okay, so from this positive terminal, this red color wire is going to the positive terminal of the ammeter. Okay, and what is the next connection? The negative terminal of the ammeter goes to the input of the rheostat. Okay, so this is the negative terminal of the ammeter which goes to the input of the rheostat. This is nothing but positive terminal of the rheostat, and the output of the rheostat is connected to the negative. So the output terminal of the rheostat is connected to the negative. You see here, it started flowing, it flows into the ammeter, it flows into the rheostat, and it tries to become loop. It's nothing but like an closed path. We want to measure the voltage. So directly voltmeter is connected across the positive and negative terminal. What is the resultant positive and negative terminal? So these are the resultant positive and negative. Resultant positive are connected here, resultant negative are connected here. Okay, this voltmeter is connected in series or parallel? Parallel. This ammeter and rheostat are connected in series. Now we have to start loading our experiment. Okay, so when you start loading our experiment, what is the estimated voltage you may get here? What is the estimated voltage you may get here? So we 12 volts and 12 volts are connected in parallel. What is the resultant voltage you are going to get? 12 volts. Now I will show you how to load it. So actually we want to start taking readings with current as minimum. If the current has to be minimum, means what is the position of the rheostat? Maximum. The formula for current, current I is equal to V by R. I have to get the current readings as minimum value. Then how much resistance I have to keep the rheostat? Which position? Maximum resistance position. Okay, let's try to take the readings. So now see here. So now the equipment is on. What is the voltage rating? What is the voltage rating? 12 volts. 12 into 1. Okay. So see the current rating. Current is 0.21 into 2. Why? Because we connected to 5. So just write down the first reading. Voltage is 12 into, okay, 12.1 into 1. So this is current is 0.25. You see the connections. If you want to see the connections, this is the input terminal, this is the output terminal. Current starts flowing here and it flows across the coil and it will be collected back. And what is the resistance offered? R is equal to rho L by A. Or the length is maximum. If length is maximum, what is the position of the rheostat? Maximum resistance. Since R is maximum, current is minimum. So that's how we are getting a minimum current here. Now I am going to vary the rheostat. Now what is the position of this rheostat? What is the position of the rheostat? Maximum. So try to load it. Already we experienced these two are connected in parallel. You will get maximum current and maximum double the backup. Okay, let's try to see here. So I am going to load it for the next set of readings. So write down the next reading. 0.3 into 1. 0.3 into 1. See the voltage rating? No variation. Okay. So 12 into 1. Why? Because they are connected in which connection? Parallel connection. 12 into 1. Next set of reading. Okay. Let's try to go for 0.4. Write down. Current is 0.4 into 2. Why? Because we are connected which knob? I mean 5 amperes knob. Indicated is 2.5 and what you are getting is 5. How to convert 2.5 into 5? You multiply the value with 2 times. So this is 0.4 into 2. Voltage is 12 into 1. So next reading. So you should not make it short circuited. You should avoid the short circuit. That's why I take lesser readings. Okay. So now coming to the next one. 0.5 into 2. Next set of reading. 0.5 into 2. I mean approximately how much load we had kept? 1 ampere load already we applied. And what is the voltage rating? 12 into 1. 12 into 1. So next set of reading. 0.6 into 2 and it is 11.9. So you see here the load increases, what will happen? Input voltage will fall down. This concept is called voltage regulation. This is same in DC supply as well as in AC supply. So now the current is 0.75 into 2. Voltage is 11.9 into 1. So I am not going to take more risk here. Why? Because it is fully loaded. So make it fast. I am reducing the load. 1 into 2 and this is how much? 11 there. Okay. So we should not keep it more. You see here it's already fully loaded. Okay. So if you want to take, I am going to the next value. Make it fast. 1 ampere. 1 into how much? 11.8. So 1 into 2, 11.8. If you take the next reading, so this will become shorted. That's why, again, what is the position of the rheostat now? Maximum. What is the value you get? Reduced value. So this is how the procedure we have to do it. So if you don't follow this procedure, there is a chance if you bring this rheostat to where? Minimum, automatically this will act as what? Short circuit. Automatic ammeter will act as an short circuit, ammeter will damage first. This ammeter effect will directly fall on the fuse if it's not blowing on. The same effect will fall on the battery. If it is in the range of how much? 6 ampere, I mean 10 amperes range. Okay, if directly shorted, complete 2 batteries and this ammeter will short. Voltage will not damage. Why? It's connected in parallel. Okay, so therefore you should take care how to do the experiments. Okay, so this is how to do the experiment on parallel connection of batteries. Now you multiply that voltage and current, you will get the power. And what is the voltage of the system? 12 volts. What is the AH capacity of the system? 40 plus 40, 80 AH. 80 AH into 12. You will get energy stored by this experiment or energy stored by the 2 batteries in parallel connection. What is the power rating? Current. So already what is the current we calculated? 4 plus 4, 8 amperes into voltage. 8 into 12. We will get the power. I mean power rating of this parallel connection of batteries. This is the procedure behind how to connect the batteries in parallel connection. Okay, so you see here in parallel connection what is constant? Voltage is constant. So now how to turn off the equipment is you should keep the rheostat in which position? Maximum resistance position and turn off the MCB. Automatically the equipment is safe. So how to start it? You give all the connections as per the circuit diagram provided for you and turn on the rheostat. I mean turn on the MCB. Automatically the voltage will be indicated and current is minimum and rheostat is in maximum. Slowly you push this rheostat when you wire wound coil carefully and such a way that you can see current gradually will increase and it reaches to the maximum. And be careful, you should not short circuit and bring it to the original condition. Okay, so this is how to load the 2 batteries in which connection? Parallel connection.